Now, let's see if we can recall whenever we want to use common logarithms and natural logarithms. Remember, anytime we have a common log, the base is understood to be base 10. And we, of course, can rewrite it as log base 10 of x, or we can write it without that base given because we know it's understood to be base 10. Then when we have natural log, the understood base is base e, so we can write that as ln of x, again without having that base there because we know it's understood to be base e. So if we apply basic properties of common logs and natural logs, then we can evaluate logarithmic expressions such as these. So let's look at the first one here. We see that there is no base there written, and we have a log there, so we have the common log, so we know that it's understood to be base 10. So then, of course, if we use those properties that we have learned before, those basic properties, if we wanted to, we can take this exponent, bring it to the front, and multiply by this log base 10 of 10. Since those two things are exactly the same, then we know this log itself would just be equal to 1, so we would just be left with 4. So therefore, log of 10 to the 4th power is equal to 4. Now let's take a look at the next example here. We see that with ln, there's no base written there, but we know it's understood to be base e. So we can rewrite it as ln base e of 1 over e to the 5th power. Well, if you notice we have this base e and we have this e to the 5th power here, we have this 1 over that, so we can actually rewrite what we have in parentheses there. And so we can write it as e to the negative 5th power. So here it was a positive 5 in the bottom. Bring it up to the top, that becomes a negative now. Well, you will notice that we have this base e, ln base e, and we have this e as our function here. Similar to what we had over here, anytime the base and the function here, or that value there, are exactly the same, then we can use that basic property, and what we have left there is negative 5. So negative 5 would be the answer to this logarithmic expression. Now if we take a look at the next one here, if we just look at exactly what we have, we know the understood base is e. Let's see if we can apply one of those basic properties and solve for that expression. Alright, in the next example here we have 10 raised to the log of the square root of x, where we can see no base is there, but we know the understood base that goes with the log is base 10. So we can simply rewrite it with that base 10 there. And then if you remember one of those basic properties, remember we had this, we would sometimes rewrite this part as equal to y. And then we would set this equal to maybe another variable and see if we can rewrite it in the exponential form. And so if you remember, if I have this base 10 here, raised to a log with this being the exact same base, if you remember that basic property, it's just simply going to be equal to the function that we have here. So therefore, 10 raised to the log base 10 of the square root of x is just simply square root of x. And so if we look at this last example, it's very similar to what we have over here. Instead of having the base 10, we have the base e that goes with the natural log. And so let's see if we can apply that same property as we did to this one in question or part D here to this function. Now let's take a look at the change of base property. So most of the time when we use our calculator, the calculator only understands base 10 or base e. But what if we do not have a function, a logarithmic function of base 10 or base e? If that's the case, then that's when the change of base property comes into play. So let's suppose we had some function, some logarithmic expression, log base b of m. And let's suppose base b is anything but 10. Then we can rewrite this such that we have log of base a. A can be any number. In this case, since the calculator understands base 10, let's suppose it's base 10. So log base 10 of our function m divided by log of that same base 10 of our base that we had here, base b. So in other words, we can write that in two ways. Log base b of m is equal to log of m over log of b. Again, there's no base given there, so we know it's our understood base 10, which is what the calculator understands. Or instead of writing log, we can write the natural log in that place. Again, we know the understood base for natural log is base e. So this is how we can rewrite it so that we are technically changing the base such that we can use our calculator. So let's take a look at these examples here. We want to use a change of base property so that we can evaluate each of these expressions. So you can see with this first example, you can see that our base is not base 10. So we want to see if we can rewrite this using that change of base property so that we could eventually plug that into the calculator. Well, remember, we can take the log of the function or the value we have here divided by the log of the base. So therefore, rewriting it this way without that base written in there, we now know they have the same base. It's not there, understood to be base 10, and we can simply plug this into the calculator. So we'll do log base 4 divided by, log of 4 divided by log of 5. And so when you get that in your calculator, you'll get approximately 0.86. So that will be the value of this expression, log base 5 of 4. Now let's do the same thing with the next example here. Again, you can see that the base here is not base 10, so we can use that change of base property again to rewrite this function so that we can eventually plug it into the calculator. So we can rewrite it as log of 8 over log of 0.5. Then we can simply just put that in the calculator, and we would get that to be equal to -3. So log base 0.5 of 8 is equal to -3. All right, next example, same process here. We see that we do not have a base 10 that the calculator understands, but we can simply just rewrite it as log of 52 over log of that base pi. Put that in your calculator, and we would get that to be approximately 3.45. So again, that's how we can apply the change of base property so that we can use our calculator, since the calculator technically only understands base 10.